Welcome to Just Calculus. This channel is all about calculus and I want to help you succeed in calculus. Today we'll be talking about integration by parts and we'll be using the traditional UDV format to solve 5 integrals. The first one is the integral of square root of x times ln x. And let's take a look at the formula, which says the integral of UDV is equal to UV minus the integral of V du. In another word, you see that we are going to break this integral into 2 parts. The first part is u and then the other part is dv. And we will be differentiating u so we can get the du. We will be integrating dv, so that's how we can get the v. So we are going to break this down into 2 parts. The first part is going to be differentiated, the second part is going to be integrated. And let's go ahead and put this down in this format. I will highly recommend you guys to do it this way, u and dv. Alright, so now let's think about it. What shall we choose to be integrated? Shall we be integrating square root of x? Well, we can do that, right? But how about ln x? Well, if we want to integrate ln x, the truth is we actually have to use integration by parts to do that. So that's not a good idea. Let's go ahead and integrate square root of x, which we'll write here as x to the 1/2 power, and that's also put on the dx together, and we will actually be differentiating ln x. So we have to make our selection first. Then we are going to just do the work. So differentiating ln x, we get 1 over x, and then also put on the dx, and integrate dv, we get the v, and to do that, we will just use the reverse power rule. We add 1 to the power, which will give us 3 over 2, and divided by the new power, which is the same as multiplied by its reciprocal, that's 2 over 3. So we put down 2 over 3, x to the 3 over 2. And when you integrate this part right here, you do not have to put down the plus c. Only put down the plus c for the final answer for that. Alright, the formula says we will have to multiply u and v together. And if you set here in this format, let me tell you, u and v will be on the diagonal right here. So as you can see, we have u times v. And that's the first part of the answer. It doesn't have any integral anymore. So let's go ahead and write that down. So I'm going to put that down first. 2 over 3x to the 3 over 2 times ln x. So that's the uv part. And then we will have to minus the integral of v du. V is right here and du is right here. The truth is, we will just multiply these 2 things in this row, and we will still have to integrate that. So we are going to minus, put these 2 together in an integral, and let me write this down first. We have 2 over 3x to the 3 over 2 times 1 over x, and let's also put down the dx right here. So that's pretty much how it goes, and now we will just have to work this out. That will be it. Well, x to this power times 1 over x, we can reduce that. This is x to the first, so we'll just do 3 over 2 minus 1, which is going to be 1/2. So if you just take a look right here, we will have to minus. We can put the 2 over 3 in the front, and then we have the integral, and this is just x to the 1 over 2 power, and then the dx. We did this one over there already, but let's do it again. I 1 to the power, which is 3 over 2. Divided by the new power, which is multiplied by its reciprocal. So now, that's pretty much it. We will write down the first part, which is 2 over 3x to the 3 over 2 times ln x. And then this times that is minus 4 over 9, and we have x to the 3 over 2. So that's it. It's not so bad. I can put on the plus c, and that's the answer. Now for the second question, we will have to integrate x times cosine of 3x. And let's just go ahead and put down the u and dv to get ready. But this time, shall we still be integrating x to some power? Let's try. X to the first power, and then put on the dx, and then that will give us to differentiate cosine of 3x. So it seems okay, because we can totally differentiate this. We get negative sine of 3x, and then don't forget the chain rule, multiply by the derivative of 3x, which is the 3. And to integrate this, it seems totally okay as well. V is going to be 1/2 x squared. Alright, And if we continue, we see that we multiply this and that together. That will give us the first part of the answer. But now, the problem is that we will still have to deal with the integral of this times that. We have x squared, and then this right here is a sine function. That integral, it's actually harder than the original integral that we're trying to do. So in this case, we are actually not going to be integrating x to the first power. So this is actually not the right choice. With that being said, don't give up. We'll just try another direction, right? We'll just be differentiating x and then see what will happen. Here we go. Differentiating this, we get du, which is going to be 1, and that's put on the dx, and integrate cosine of 3x. Well, when we integrate cosine, we get positive sign, and then the input stays the same. And we can do this is because the derivative of the inside is just going to be a 3. So we do this, and we are doing the reverse chain rule right here. So divided by the derivative 3x, which is multiplied by 1/3. So that will be the idea. And now let's see, this times this. That's the first part of the answer. So we will have 1/3, and then x, and then sine of 3x. So this right here is the uv part, and then we will just minus the integral of the product of this row. So let's see, we minus integral 1 times that, which is just that, 1/3, and then we have sine of 3x, and that's also put on the dx right here as well. Okay, you see, now we don't have the x to bother us anymore. So to integrate this, we can look at this as minus 1/3, and then integral of sine of 3x. Well, integrating sine, we get negative cosine. So this right here will actually give us negative from here, but another negative will make this positive. So we get cosine 3x right here, but don't forget that we will have to divide it by the derivative of the input, which is 3. So we will have to put on the 1/3 right here. So that will give us 1/9. So just like this earlier, right, we go this way, we divide it by the 3. So when we do it again, we will divide it by the 3 one more time. So that will take care of this integral, which is very nice. And now we can just write down what we have right here. 1/3 x sine of 3x plus that, and we're all done. So we'll just put on the plus c, and that will do it. For number 3, we have the integral of 2x minus 3 times e to the 4x. So let's go ahead and write down the u and dv to get ready. And now, what shall we choose to be integrated? Shall we choose this 2x minus 3? Well, if we do that, we get x squared minus 3x. And that means we will have to differentiate e to the 4x. And you'll still get e to the 4x and times of 4. So that second integral that we get, it's not going to be any easier. So we shall really be integrating this e to the 4x. And then we will differentiate 2x minus 3. And you will see things will work out really nicely. Alright, du is just going to be 2 dx. And then this right here, okay, we have to integrate both sides. That's how we can get the v. And because the derivative of 4x is just a 4, so we can just put down e to the 4x and then divide it by the 4. So that's put down 1/4. Alright, so first part of the answer, this times that, that's the uv. Okay, so I will put down the 1/4 right here and then multiplying with 2x minus 3 and then e to the 4x. Then we continue, we will have to minus the integral, which is just the product of these two things from this row. And we will put down inside of a minus integral. And here we have 2 times 1/4. So perhaps I'll just write down all those things. 2 times 1/4. And then we still have the e to the 4x. And of course the dx. Alright, this right here is just of course 1/2. And when we integrate this right here, let's see, we will get negative, we have this 1/2 right here. And then we have that e to the 4x. But just like what we did earlier, we will have to divide by the 4. So let me just indicate that right here. So altogether, this is what we have. 1 over 4 times 2x minus 3, and then e to the 4x, and then minus this times that, which is 1 over 8, and then we have e to the 4x. Yep, that's it. After we put on the plus c, now we'll do it. Okay, for number 4, we'll be integrating inverse sine x. And the truth is, whenever we are trying to integrate an inverse function, usually it's integration by parts. So just like this right here. So let's go ahead and put on the u and dv. And let's think about it. What shall we choose to be the dv? Should we put down inverse sine x right here? No, of course not, because we're trying to integrate inverse sine x. So do not put this down right here because that defeats the whole purpose. So that means we have no choice but to differentiate this right here, right? So let's go ahead and make that happen. Now, what should we choose for the dv though? There's nothing else. Don't forget we still have the dx, and this is like saying 1 times dx. So the truth is we'll be integrating 1 dx, like that. Now let's make things happen. We will have to remember our derivatives really well, because when we differentiate inverse sine, yeah, it's just a matter if you remember it or not. 1 over square root of 1 minus x squared dx. Well, you can try to prove it, right? But like, just remember it, that will be the goal. All right, for this, we integrate this, integrate that. Integrating this, we just get x, because we're like integrating 1. So now, let's go ahead and do u times v, which is just that diagonal. That will give us the first part of the answer, which is this times that, x times inverse sine x. And then we have to minus integral, and we are going to put these two things together inside of that integral. So we have x right here, and then I will just put that down over square root of 1 minus x squared, and we also have the dx. So that will be it. Now, to integrate x over square root of 1 minus x squared, we can actually just do a u substitution. So let's go ahead and make that happen on the side. Let u, so this u is very different than that u. It's in blue. No, just kidding. I'm doing this u substitution for this integral. All right. Well, of course it's in blue. I wasn't kidding about that. But anyway, let's continue. Pick u to be that 1 minus x squared, and we will see that du will be negative 2x dx, and then dx is going to be divided on both sides. We get du over negative 2x. And now let's just take a look at this integral. We have the minus, let me also bring the minus down right here. The integral, and x is just right there over square root. This is our u, and then the dx is that du over negative 2x. And we see this and that cancel nicely, this and that cancel nicely. And remember, I brought the negative with me already, so just keep that in mind. Now, we can put the 1/2 in the front. And then integral, we have square root on the bottom, so we'll write it as u to the negative 1/2 power in the u world. To integrate this, we add 1 to the power, which will give us positive 1 over 2. Divided by the new power, we multiply by 2 over 1 right here. And then you see this and that cancel. So we end up with u to that power, which is just square root of u, and u is that. So that's 1 minus x squared. And you see, the whole thing will just be that. And that's pretty much it. So finally, I will just write this down for you guys. This is x times inverse sine x. Negative, that integral is just all that, and that's actually a positive, so I'm going to be writing like this, plus the integral of 1 minus x squared, just like that, and then we are done. So put on the plus c. That is it. For number 5, we'll be integrating x times secant square x. So of course, let's go ahead and put on the u and dv to get ready. And now, what should we choose for the dv? X or secant square x? The answer is secant square x. And let's just go ahead and put that down and then work things out and see if it works or not, right? Okay, u will be just x, and you see when we differentiate that, we get dx. And now when we integrate secant square x, okay, derivative of what function will give us secant square x? The answer is tangent x, So we get v equals tangent x. Now we multiply this and that. That's the first part of the answer, which is x times tangent x. And then we multiply this row, put that in the integral, we have to minus that, which is just tangent x times dx. Now, can we integrate tangent x? Yes, this is actually just a standard integral, and you can just write down the answer for that. So I will just write this down again, x times tangent x, and then we have the minus. And ladies and gentlemen, the integral of tangent x is just ln absolute value of secant x. You can just write that down and you can use this as a standard result. That's all. And we're all done. So of course, put down the plus c, and this is it. So hopefully you guys find this video helpful, and if you guys need more help with integration by parts, you guys can check out my next video, which is integration by parts, but with the DI format. Definitely do the DI format rather than this one right here. And you guys can also subscribe to the channel for future videos. I will have more calculus videos for you guys. So as always, that's it.